Hello friends, we move on with the next topic and we will go through the Millmans theorem in our next topic. Okay, we have already gone through the superposition theorem in my previous video. Please go through it. Now we move on with the Millmans theorem. If you have still not subscribed, like and comment my channel, please do it, because once you subscribe it will be more easy for you to go through my all videos. Okay, so we start with our next theorem known as Millmans theorem. So friends, what is Millmans theorem? The first very important thing is Millmans theorem is also known as parallel generator theorem. Please keep in mind, this question sometimes used to come. What do you mean by parallel generator theorems? And you have four options like this theorem is this theorem is this theorem is this, like that. So please keep in mind, Millmans theorem is also known as parallel generator theorem. It is because, see, you will see Millmans theorem is applicable in the case when parallel combination of voltage and current sources are present. So Millmans theorem actually states that any parallel combination of voltage and current, I have taken case 1 and case 2, please try to understand. So the parallel combination of these voltages or current source can be combined in this form. So this is the statement of a Millmans theorem, and where you have to find the value of V and R in this case. Similarly, you have to find the value of V and R in this case. Okay, so I have just taken case 1, case 2 to understand about the Millmans theorem. So as I said, Millmans theorem is basically explains about how you can convert this parallel combination into this form. So if it is your load RL, so this is your load RL, and finally you convert this entire bay into one voltage source in series with this resistance R. Now you have to find the value of V and R. Okay, so this is all about the statement of Millmans theorem, that number of parallel voltage and current source may be converted into voltage and resistance in this form, and you have to find the value of V and R. So just keep in mind, we will directly find the value of V and R with the help of Millmans formula. So V is given by what? It is V1 into G1. G1 is what? That is conductance, 1 by R. G is what? As I already told you, it is 1 by R. Please keep in mind. So V1 G1 plus V2 G2. Now if there are n number of sources, so that comes to be Vn Gn upon G1 plus G2 plus G3 plus up to dash dash Gn. Okay. So the voltage V is given by V1 G1, G is your conductance, that is 1 by R. So V1 G1 plus V2 G2 plus V3 G3 plus up to dash 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 Vn Gn upon G1 plus G2 plus G3 Gn. This is your voltage V, and if you talk about resistance R, so that comes to be a parallel combination of resistance, so that we will directly write as G1 plus G2 plus G3 dash 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 Gn. So finally this is your V and this is your R. So with the help of these two formula, one can easily find the value of V and R, and just by applying concept you can find the value of current and voltage across the load. Okay, so this is all about the Millmans theorem for the case 1. Now we will see for the case 2. Now when we will see for the case 2, please see, in case 2 again there are voltage source in series with resistance, and now you will find some current sources present. So under this condition, what is the value of V and what is the value of R? This you have to find. So just please see, in this case again it is V1 G1. First of all, we will consider all voltage and corresponding resistance. Now you see, this is the current. Actually V and V1 multiplication of V and G is what? It is basically current. Okay, so now here only the current is given, so here directly comes to be I1. Here the current is going in opposite direction, so this comes to be minus I2. Please keep in mind, very important thing, upon again G1 plus G2 plus G3. Since there are only 3 resistance present, so it comes to be what? G1 plus G2 plus G3. So this is a case in which I have taken 2 current source also. Okay, so this is actually the value of your V. Now when you have to find the value of R, how will find the value of R? For finding out the value of R, I will find it out here. Now please see, here I can write the value of R. The value of R again comes to be what? It is 1 upon this G1 plus G2 plus G3. This is the value of R for this case, and this is the voltage. Okay, so this is all about the Millmans theorem, in which we see that the number of parallel sources converted directly into this form. Similarly here also we have converted into this form. The only thing is here 2 current sources is given, I1, I2. Please keep in mind the direction of the current source. As we have taken the direction upward as positive, so it is plus of I1. When it goes in opposite direction, this is minus of I2. So this is all about the Millmans theorem. Now we will see one problem in this section. Okay, so friends, we see this problem under Millmans theorem. This is a problem in which you have to find the value of current I. In this problem you have to find the value of current I. So friends, this is our problem in which you have to find the value of current I, and we will find this value of current I with the help of Millmans theorem. Okay, so as per Millmans theorem, if I draw the equivalent circuit, it should be something like this, and here is your resistance. If you say this is I, this is your 6 ohm, I will call this 2 terminal as AB. So basically you have to find this R and this V. Okay, and once you know the value of V and R, you can find the value of current I which is flowing here. Okay, so as per our formula for Millmans theorem, that is V is equal to how much it is? It is V1 G1 plus V2 G2 plus V3 G3 plus V4 G4 plus V5 G5 whole upon, it is G1 plus of G2 plus of G3 plus of G4 plus of G5. Now this is your V1, V2, V3, V4, V5, and this is your R1, R2, R3, R4, R5, and we will convert it into G1, G2, G3, G4, G5. The relation between G and R you very well know, that is 1 by R. Okay, so I am directly finding this value V, how much it is. Now see, V1, it is your 1 volt, so 1 into G1 is what? It is 1 plus of V2, it is your 2 into 1 by 2 plus of 3 into 1 by 3 plus of 4 into 1 by 4 plus of 5 into 1 by 5. Okay, this upon G1, it is 1 plus, it is 1 by 2, it is 1 by 3, it is 1 by 4, it is 1 by 5. So this is basically the value of V. We will find what it is. So you can directly write here the value of V is what? It is 1 plus 1 plus 1 plus 1 plus 1 upon, okay, 1, 1, 1, 1, 5 times, okay, upon how much it is? It is 1 plus 0.5 plus 0.33 plus 0.25 plus 0.2. Okay, so that comes to be 5 upon how much it is? 0.45, 0.95. I will solve it and one can get the answer. it is 2.28. So V comes to be how much? It is 2.2 volt, you can say. This is the value of V. Okay, so this value V comes to be how much? It is 2.2 volt. Okay, now you have to find the value of R. So see, what is the value of R? Now you have to find the value of R. Okay, so the value of R is what? It is 1 upon G1 plus G2 plus G3 plus G4 plus G5. Okay, this is the value of R. So this I write earlier, it is 1 plus how much? It is 0.5 plus 0.33 plus 0.25 plus 0.2. So that comes to be 1 upon 2.28. That comes to be how much? This comes to be 0.439 ohms. So this is the value of R. So you got the value of R as 0.439 ohms. So now can you find the value of I? Yes. By solving from here, you can say V is equal to R plus 0.6 into I. So I is equal to V upon R plus 6. So V is how much? It is 2.2. R is how much? It is 0.439 plus of 6. So that comes to be how much? It is 0.342 ampere. Okay, so the value of I comes to be here what? This I is equal to 0.342 ampere. This is the answer. Okay, with this you have just solved the Millmans problem. Okay, so we'll not solve much problem under the Millmans because you have already seen when you apply the concepts of Thevenin's and Thevenin's and Norton's, through that theorems itself you can able to find the value of I. It is just to understand the concept how Millmans theorem is applicable, and with the help of V and R how one can able to find the current or voltage, whatever the parameter which is asked about the load can be easily find. Okay, so